Okay. Alrighty. 9x squared equals 4. What's our first step to solve for x? Can't get rid of the square root first, because why? We do have to do that, yes. But what do we need to first do? What's like attached to the x squared? We have to divide by 9 before. We don't have to, but we should. Let me clarify. You could square root this first, but we should always try and get our x, our variable, by itself first. Does that make sense? Okay. So we're going to divide by 9 first. So we end up with x squared equals 4 over 9. And then we can take the square root to get rid of our x squared, which these cancel out. How can we rewrite the square root of a fraction to help us a little bit? Remember when we had a division inside a square root or multiplication, we can separate things, right? No? Anyone remember? So what we can do is the square root of 4 divided by the square root of 9. Do you guys remember that now? And then that becomes x equals what? What's the square root of 4? 2 over what? 2 over 3. Am I missing something? Well, I have x right here. When we take the square root of something, what do we always want to account for? Do you guys remember when you take the square root of something, you always want to have plus and minus in front of it? So when I did this, I should probably have right here plus or minus. Yeah. Make sense? Okay. 25x squared plus 2 equals 6. What do we have to do first? Subtract 2. What do we get? 4. Yep, 25x squared equals 4. All right. So we get 25. And then what do they want to do? Divide by 25. So we end up with x squared equals 4 over 25. And then what do we do? Not yet. We have to do something first. Take square root. Yep. Take square root, and then we can separate these. So this cancels out, and we get x equals, don't forget your plus or minus, square root of 4 divided by square root of 25, which x equals plus or minus what? 2 over 5. Make sense? And then we've got negative 3x squared minus 34 equals 47. What do we do first? Add 34. Got next negative 3x squared equals 81. And then what do we do? Not square root yet. What do we have attached to our x squared? Yeah, we got negative 3 attached to it, right? So we want to get rid of that. So what do we do to get rid of that? Divide by negative 3, yep. So you end up with x squared equals what? Oh, sorry, thank you. Yep, it is a, nope, that's the wrong button. It is a cubed, you are correct. What'd you get? Yes, negative 27. All right, so then, yep, you take your cube root, right? Take our cube root of both sides. This cancels that out. So we got x equals cube root of negative 27, which is not just 3, not plus or minus 3, because with cube roots, we either have a positive or negative answer.
Negative.
Yeah. Negative 3, right? All right. Is this making sense? This was just kind of review over some things we did last chapter, because we're also going to still be working today with equations and solving for x as well, just in a little bit of a different way this time, okay? Everyone good on this? Sort of, yeah. Okay. Can I flip the page? Okay. Cool. So you get your workbooks out. Page 365 is where we're going to be working today. Oh, sorry. Alrighty, everyone there, 365. Okay, so today we're starting the next section of chapter 7, 7-2. It's solving exponential equations and inequalities. So we're going to be working through these two concepts today. So our first one is the property of equality for exponential equations. This is super important because this is going to help us understand how to solve the equations when our variable, as you can see here, is in an exponent, okay? So it says that if b is greater than 0 and it's not equal to 1, so if you see here, if b is greater than 0 but not equal to 1, then b to the x equals b to the y if and only if x equals y. Okay? how we're going to use this, we will see in a second. It is going to be maybe a little difficult at first how to visualize this. So real quick, before we do our first example together, I want us to run through a few things. If I have two, that's not what I wanted. 2 to the negative 4, or let's not do that big of a power. 2 to the negative 2 power, what does it do for me? What does it do to the 2? What does a negative power do to a fraction? Or to a... It makes it a fraction. Yeah, I just gave you the answer. Yes, it makes it a fraction. So this can become 1 over 2 squared, which then we know is also 1/4. Make sense?
I have a question.
Yeah.
I don't understand the dy, xy. Do you have like a formula for that?
So, not exactly. What this is just saying is, and we'll see it in our first example, when we get the same bases, right? So, let's just go through the first example, and then I'll come back to that question, okay? We want, in our equations, to end up with the same bases, okay? So we want b's to be the same, or we can't solve the equation, okay? If our b's are not the same, we can't do anything. So we have to manipulate our numbers to get b to be the same number on both sides, okay? That's just basically what that's saying.
I don't know what
B is just going to be these numbers right here. Okay. So if we have 2x equals 2 squared, does that make sense? So these are the same numbers. And what this is saying is that we can then, it says, then we can set x equal to y. So then we can set x in this equation. We can set x equal to 2. Do you guys see that? Yeah. So we get our bases to be equal. We can take their exponents and set them equal to each other. And this is going to be super helpful because when we have a variable in the exponent, we need to solve for a variable, right? So for this first example, looking at 4 and 64, what are their greatest common factors that, or what do I want to say? Yeah, greatest common factors? Yeah, that they have in common with each other. What are factors that they have in common with each other? Think about what 4 is divisible by. 2, okay? If we know 4 is divisible by 2, what times 2 gets us 4? 2 times 2, which is also known as 2 squared, right? All right, and we still have our, sorry, let me move this over a little bit. 2 squared, okay? I'll come back to that power in a second. 64, if we were to birthday cake this, and we want to get it down to, we want to get same bases again. So we want our base to be 2. We got to figure out how many 2's we're multiplying by each other, right? So 64 divided by 2 is? 32. Divided by 2? 16. Divide that by 2? 8. Divide that by 2? 4, divide that by 2, shoot. 2, and we get one more 2, right? All right. Okay. Scratch all that. We have 1, 2, 3, 4, 5, 6. So, I might be making this a little bit more complicated than I needed to go. That's my fault, guys. I'm so sorry. Can I back up? Okay, I'm gonna back up real quick. I'm making this too complicated. Okay. Let's think about 64 in terms of 4. Since we already have 4 over here as our base, and we know 64 is divisible by 4, right? If you were to divide 64 divided by 4, what do you get? Okay, 16. That's beautiful. So 64 equals 4 times 16, which, what does 16 equal when you divide, well, what is 16 divided by 4? 4. All right? So 4 times 4 times 4 times 4 equals 64. Do you guys see that? I just basically did birthday cake a little bit, but the problem is with birthday cake, you're supposed to do primes. 4 is not a prime number, right? So I didn't want to do birthday cake, but does this make sense? We know 64 is 4 times 16, and we know 16 is 4 times 4. So if you type in 4 cubed into your calculator, what do you get? Right, 64. So, do you agree with me when I say we can write 64 as 4 cubed? Yeah? Do we have the same bases now?
Yeah.
Are our b's the same? Good. Okay, so I can, 5x plus 1, and then still keep my exponents. The exponents always continue to follow our numbers, okay? What do I do over here to combine these exponents? When you have an exponent to an exponent, what do you do with them? Multiply. So now I've got 4 to the 5x plus 1 equals 4 to the what? $21. Yep. So now, do you agree with me that now that we have the same powers, we can take our exponents and set our exponents equal to each other? Just like we did up here, we had the same bases. We had the same bases, so we could take x and 2 and equal them to each other, right? So in this instance, what are we going to get? What's our new equation?
5x plus 1 equals 21.
Yeah, 5x plus 1 equals 21. And now we just solve for x like usual. Does this make a little bit of sense? Okay. So solve for x, we get minus 1. 5x equals 20. What's 20 divided by 5? 4. So x equals 4. Is this making some sense? Okay. Sorry by confusing you guys. I started off a little shaky. We could also get this down to 2's, bases of 2. Because 4 is 2 times 2, right? So 4 is just 2 squared. And then we know 4 is also the same thing as 2 squared. 64. Do we know how many times we multiply 2 to get 64? Two to the what power? 6. Yep. So we could do this as 2 to the 6th power. And then we could plug those in like we just did for 4. And we get 2 squared, 5x plus 1 equals 2 to the 6th. To the 7th power still. Okay? You see that over here? We're still going to get the same answer though. Okay? We can do that. 10x plus 1 equals, what's 6 times 7? Oh, wait. Do we get the same answer? No, I don't. Oh, I know why we don't get the same answer. It's because I multiplied wrong. 10x plus 2, there we go. 42, yep. We subtract 2. 10x equals, when we subtract 42 from 2 from 42, we get 40. Divide by 10, what do we get for x? 4. Do we have the same answer? Okay. It's always a good idea to look at our bases, and if we don't have to simplify one of our bases, then don't do it. So when I started trying to simplify them into 2's at first, I was making it more complicated, so that's my fault. But you can do 2's if you want to, okay? Do you see that you're gonna get the same thing for x? Is this making some sense? Okay. So we're gonna do this other one. Over here, we have 1/2 to the 4x minus 16 equals 16 to the 2x minus 5. 1/2 is just the same thing as what? If I were to tell you that I want it in base of 2, 2 to the what power is the same as 1/2? Not just the first, but the, how do we get a fraction? Yeah, 2 to the negative first power. So we can rewrite 1/2 as 2 to the negative first power, 4x, keep bringing down our exponents. All right, and then we want to get 16 to a base of 2. So, how many times do I multiply 2 to get 16? Well, 2 times 8 is 16. Yes, it's 2 to the 4th power. We're thinking in exponents, okay? If we were to, I'm just going to do this down here, say 16 equals 2 times 8, that's totally good, right? But we got to keep breaking it down. 8 times 8 is 2 times what?
4.
2 times 4. So then we could write this as 2 times 4. And then 4 is 2 times what? 2 times 2. Do you see that? We got 4 2's, so 2 to the 4th equals 16. Does that make sense? This is just, we just basically just did birthday cake in a different form. Okay, that's what we just did down here. So you don't have to do this way. You can do a birthday cake, or you can think about, okay, 16 is 4 times 4, which then is just 2 times 2 and 2 times 2, okay? All right, I'm gonna erase that part because we gotta finish our equation. All right, so then what's our next step? What do we do with our exponents? Multiply them. Negative 4x plus 16. And then we gotta do 4 times 2x minus 5, 8x minus 20. What do we do now? We have same bases now, so what can we do? Set our exponents equal to each other. So we get negative 4x plus 16 equals 8x minus 20. All right, and then we can add 4x over, and then add 20 over to this side, and we'll get 36 equals 12x. Solve for x. What do you get? What's 36 divided by 12? 3. Yep. So x equals 3. And if you want to check yourself, you could take 3, you can plug it back in for your x's up here, and then literally solve using a calculator. And you should, and you will get equal numbers on each side. Does that make sense? Okay. How are we feeling about this? Look, on a scale from 1 to 10, how are we feeling? If you want to put up fingers to show me, you don't have to tell me. Okay? Okay. 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 Do you guys want to do one more practice of these together? Maybe? Yeah, okay. Let me get a new page. Get a problem to do. Let's do sorry guys, we're gonna do number 2 in your books together. So it's actually one of your homework problems, fun fact. So if you do it now with us, then you'll have a homework problem done. So it's 9, oh my goodness, 9 to 8x minus 4 equals 81 to 3x plus 6. All right, looking at 9 and 81, what do you think our base is going to be? 9. Yep. This is a good place to start. Always looking at your 2 bases here, thinking about a common factor they both have. For this one, we get to keep one of our factors. So we're going to keep one of our bases the same, which means a little bit less work for us. So we know we want to keep 9, so this side doesn't change, okay? 81. As a base of 9, what is 81? 9 squared. Yep. So 9 squared, and then we take it to the 3x plus 6 power. So 9 to 8x minus 4. What do we do on the right side? Multiply our exponents. What do we get? Yep. What do you get? 6x plus 12. Good. What do we do next? Set them equal. 8x minus 4 equals 6x plus 12. And then we solve for x like usual. Plus 4. 8x equals 6x plus 16 minus 6x. How much room am I running out of? Get 2x equals 16. So x equals what? 8. Yeah. Where did what? The 9. The 9s? Yeah. Okay, so this is from our first, I'm gonna skip back real quick. I'll come back to this page. Oh, this is from this property. This property says that if our bases are equal to each other, then we can just take their exponents and equal them, or set them equal to each other, okay? So in this case, our bases were 4, and once we got our bases the same, we could take their exponents and set them equal to each other. Okay? And this one, we got them down to 2. Once we got both of them down to 2, we could set our exponents equal to each other. Okay? And then this one, once we got 81 written as 9 squared, we had the 2 same bases, we could take their exponents and set them equal to each other. Okay? Does that make sense?
Yeah.
Alright. Do you guys want to do one more? Or we have to change both sides again? Or do you guys want to move on to inequalities? Inequalities are going to be very similar. The only difference is that instead of an equal sign here, it's going to be an inequality sign. Okay? So we're going to be doing the same practice, basically. So let's move on, and then we can always come back and do extra problems, okay? So we're going to flip to page 368. So we're skipping over pages 366, 367, and then example 3 on 368. And we're just skipping to the learn solving exponential inequalities and then example 4, okay? So, as you can see here, we have a very similar property to what we just had. It's saying that as long as b is greater than 1 and b is greater than x, or b to the x is greater than b to the y, we can set x are greater than y, okay? And then it's the opposite if the sign is flipped. So if b to the x is less than b to the y, x will be less than y, okay? The only thing that changes here is that instead of having equal signs, you have inequality signs, okay? So nothing huge. It's just we're changing the signs that we've got. You feeling okay about this? So all of the math we were just doing is the same, okay? So, let's just do our first problem together then. Example 4, we have this 27 to the 2x plus 6 is greater than or equal to 81 to the x minus 5, okay? Think about 27 and 81. What is a common factor between 27 and 81? 3, yeah. 27 is 3 to the what?
6.
Not 3 to the
7.
6. It's smaller than that, actually. How many 3's do we have to multiply by each other? Type in 3 to the 4th, what do you get? 81. So what'd you say? 3 to the 3rd. Yep. I'm writing that too far over here. 3 to the 3rd. 2x plus 6. Sign stays the same. So 81 is 3 to the what? 3 to the 4th. And then our exponent. All right, next up.
Times by the exponent.
Yep, multiply by the exponent. So we get 3 to the 6x plus 18, because 3 times 6 is 18. Sign stays the same. And then what do you get on the right side?
Minus 20.
4x minus 20. Yep. All right, next up. We have the same bases, which means we can do what?
Drop it down.
Yep. We can set them equal and drop just our exponents down. Okay? Again, sign stays the same. All right, and then we solve for x. So we get, if we subtract 4x over, we get 2x. Then if we subtract 18 over, we get 2x is greater than or equal to negative. Ooh. What's 18 plus 20?
38.
38, yep. And then we divide by what?
2.
2. So we get x by itself over here is greater than or equal to what?
Negative 19.
Negative 19. All right. And then sometimes for your problem, your answers for these, it'll ask you to like make the solution set here. It'll say the solution set is where x is greater than or equal to negative 19. Okay? So this is the smallest x that this is true for. That's what that's saying. Okay? Does this make sense? Is this making a little bit more sense? Good. So again, what? Oh, shoot. Okay. So, real quick, this is, again, just like we were doing, the only difference between the equations and the inequalities is that we have inequality signs. One rule, and I need to check the homework, this is my fault for not checking yet. One rule is when you divide by a negative with inequalities, what happens to the sign? It switches. So don't forget that. We don't have any practice with that because I don't know if the homework's got that. But if we do, we can work through some of those tomorrow or on Monday, okay? Before the announcements, we're not going to finish the solve. That's okay. We can finish it tomorrow after bell work. What are going to be our like bases?
5.
5. What is 125 equal to?
5.
5 what?
5 squared.
That's
5 squared.
That's 25, right? 25 is 5 squared. So 125 is 5.
To the 5.
Small.
4.
Anyone know?
Type them in your calculator and go, all right, 5
Yep.
times 5.
5 cubed. Yep. Okay. Then we, again, multiply exponents to each other. And then once we have the same bases, we can set our exponents equal. Or in this case, using the inequality sign. All right, everyone feeling okay about this? We'll have more work on it tomorrow. Tomorrow we're doing a skills check. It'll be an open note skills check. Homework is listed here. Oh, yeah, perfect. Yeah, so skills check is tomorrow. It's open notes. Your homework problems are listed up here. And then again, tests will be in roughly 2 weeks from today. So good job today, guys. We struggled through it together.